Hello everybody! Welcome to our little video for Lab 8, which is of course solar rotation and sunspots. I just want to do a couple of things quickly with you, namely introduce you to the spaceweather.com website, which is what we're looking at, and also give you some ideas on how to actually do this lab, which is a fun lab. Let's take a look over here at every day they have a new image of the sun. Here's what it looks like. This is the version you're going to want to use. You can make this bigger, but this is a spotless sun. That's what we're stuck with these days. So they're just passing through solar min. Notice you can see statistics on it down here. Current stretch, we have 11 days with no sunspots. 220 total, 74% of the time no sunspots. Last year it was 77% no sunspots. So we're going to have to use the archive, and that's over here on the right. But before I show you that, this actually has all sorts of interesting stuff in it. You may want to take a close look at it just in general outside this lab. Down here they have a plot of recent recorded fireball orbits that they've computed. Down here, the other thing that's fun is a list of upcoming Earth asteroid encounters, and they have them here hyperlinked for you. Also the miss distance. LD means lunar distance. The moon's about 250,000 miles away. Some of these shouldn't even be on the list. I mean, 15 lunar distances is not a close approach, but they do give you diameters, 41 meters. There are some big ones, almost 200 meters. That would make a big splash and be very devastating for the Earth. Let's go up here, take a look at what you're going to be doing. Here's the archive up here. Let's try August 18th and show you what spots are there. You could use any of these as long as there are 6 days worth of sunspots. We want the 18th, there it is right there, and this is for 2017. And the fun thing is they'll actually show you, there it is right there. And there are spots, so let's bring it up a little bit so you can actually see them. Are you ready? There we go. Yeah, I didn't want to do that. There you go. So this is showing you, there's the number 2671. This is a huge sunspot group, by the way, and notice where it is. Probably if you're going to use this, you'd pick this spot and this spot, because you never know if these other spots are going to be around. Let's go back and talk about how you'd actually plot these things. What I would suggest is when you're going to be doing 6 plots for 6 consecutive days, make sure that the top of the page at the top when you're reading the language on the page, is aligned parallel to the top of the image. And I mean, this is the top of the image right here. Don't angle it or twirl it around, or you'll get weird plots, which you don't want to do. And you can, we'll take a look at this. There's a lot of structure here in this group, which is very interesting. Let's go back and look forward in time a little bit with this thing. Let's look at the 20th. You're going to be taking consecutive days, but I want to look a little bit further up for you. There's the 20th to show you how it evolves. Anything can happen with sunspot groups. You can't expect them to be around for you when you want them to be. I don't know why that big white square is there like that. Notice what just happened. They're moving from left to right. This is a particularly good one to follow. And I'd still suggest you take the first one and the last one, because you don't want to try to plot all of these. Make sure that you keep your paper aligned. This is actually a very nice, tidy group that could give you a very nice value for the rotation rate of the sun. Now, what you need to realize is that if we were to see a spot group come on, say, the left edge, and then we watched it go off the right edge, and that would have happened within 6 days, it would be reasonable to conclude that half the period of the sun was about 6 days. And so the period of the sun would be about 12. But you're not going to be that lucky, because the period of the sun is much longer than that. So what you're going to have to do is you're going to be seeing things come on here and kind of go off here. And what you need to remember is that from here to here is going to be half the period. So you're going to have to remember 2 things, that whatever you actually move across here is going to be 6 days worth, and that needs to be compared to the distance from here to here, which is half the period. I think I'm giving you a pretty good hint here. The other thing to remember is that you're looking at a sphere, and even though we're seeing it in a flat orientation here, you're looking at it as a sphere. And so you'll have to keep that in mind too as you do this. There's no complicated mathematics assumed here unless you want to invent it yourself. But in general, just doing the sort of thing I'm suggesting here will give you a very interesting shot at getting a good period. Just remember that from one edge to the other edge is half the period. So you want to figure out how far this thing moved versus the distance from one edge to the other edge, and keeping in mind that the sun is a sphere. And that's really all there is to it in this particular lab. So anyway, good luck.